Hello again. This is section 1.8 inequalities. So in this section, we're going to look at some different types of inequalities, how we solve those inequalities, and then also how we can graph the solution sets to certain inequalities. All right, so first off, some rules for our inequalities. As long as A is less than or equal to B, we can actually add a value to both sides of that inequality and it will stay true. So similar to our properties of equations that we looked at previously, we can do some of the same things when we're dealing with inequalities. Okay, so again, if we have A is less than or equal to B, we can also subtract the same value from both sides. That's what number 2 tells us. If C is greater than 0, then we can actually multiply both sides of our inequality by that value, and the inequality will still stay true. Now, number 4, notice, if we multiply both sides by a value that's less than 0, meaning we're multiplying both sides by a negative, the thing that changes here is instead of A being less than or equal to, now we have to flip that sign and it becomes greater than or equal to. So basically, anytime you multiply by a negative number, just remember to flip that inequality symbol. Right, now, if A is greater than 0 and B is greater than 0, meaning they're both positive, and A is less than or equal to B, then we would say that 1 over A has to be greater than or equal to 1 over B. So if we create those reciprocal fractions there, okay, those are going to have the opposite inequality symbol. And then number 6, if we have A less than or equal to B and C less than or equal to D, then the sum of A plus C has to be less than or equal to the sum of B plus D. And then finally, number 7, if A is less than or equal to B, B is less than or equal to C, then the A value itself has to be less than or equal to that C value. All right, so now we're going to use some of these properties to help us solve some of these inequalities. All right, so our first one we've got here is 3x is less than 9x plus 4, and so we want to solve that, and it asks us to sketch the solution set. So first thing we're going to do here is we're going to try to get all the variables together, just like we did when we were looking at equations. So I'm going to actually take the 9x here. Since it's a positive, I'm going to subtract 9x on both sides, which is going to give us a negative 6x less than positive 4. Now at that point, just like we did with equations, we're going to divide to get the x by itself. So we divide both sides by a negative 6. That gives us our x over here. Now, anytime you multiply or divide by a negative value, we have to flip our inequality sign. So in this case, instead of less than, this one's actually going to become greater than now. And now we can simplify 4 over negative 6. 2 goes into both of those values. So we're going to get 2 over 3. And because it's a positive over a negative, the answer is going to be a negative. So our solution here is that x must be greater than negative 2/3. Now, what that means is that the x value could be any value, any real number value that's bigger than negative 2/3. So when we sketch the solution set, we're actually going to do a number line here. We're going to put negative 2/3 on our number line. And since we're strictly greater than, not greater than or equal to, we need to put an open circle at negative 2/3. So that open circle tells us that that value is not included. And now we want to shade all the values on the number line that are greater than negative 2/3, meaning everything to the right of negative 2/3. So that would be the graph of that solution set. And so again, as long as you have a linear inequality where all the variables are to the first power, we can solve this the same way we solved equations previously, get all the x's together, solve for x, get it by itself, and then to graph the solution set, we just have to think about open circle or closed circle, and then which direction are we going to shade. Okay, now example 2, we want to solve the inequalities. So we call this a compound inequality because we actually have 2 inequalities in one. So notice there's 2 different inequality symbols, but it's all written together in this case. So we have 2 options. We can either split it into 2 separate inequalities and solve each one individually, or we can actually work with these together. We just have to remember that whatever operations we do, we have to do to all 3 pieces here. Okay, so again, I'm trying to isolate the x, get it by itself. I'm going to start by moving this -2. So to get rid of a -2, I'm going to add 2. But that means that I've got to add 2 everywhere. So over here to the 4, I'm going to add a 2 to that. And then to the 13, I'm also going to add 2 to that. Well, 4 plus 2 should give us 6. Less than or equal to 3x less than 15. Now again, we're still trying to get that x by itself, so I need to divide by 3 at that point. So I'm going to divide this by 3. And again, that means I need to divide everything by 3. So I'm going to divide 6 by 3 and the 15 by 3 also. 6 divided by 3 should give us 2. This time I did not divide by a negative, so I'm not going to do anything to my inequality sign. So this is still less than or equal to x less than 15 divided by 3. It's going to give us 5. Okay, so there is the solution to those inequalities. Now, what this means, if you wanted to split it out and kind of think about it individually, this means that x is greater than or equal to 2, because I would have to flip that whole thing around, including the sign, and x is less than 5. Okay, so that's the solution set we're going to graph now. So I'm going to do my number line. This time we actually need 2 different values. We've got a +2 and we have a +5. Now notice this time x is greater than or equal to +2, meaning that value is going to be included. So I'm actually going to have a closed circle, meaning I'm going to fill it in on the left. And then x is less than 5. There is no equals there. That means there's going to be an open circle at 5. Now, I need to be greater than or equal to 2, but also less than 5. So we're only looking at the overlap between those two things. That means I'm only looking at the values that are between 2 and 5. So again, our solution here, 2 is less than or equal to x is less than 5. And then the graph of that solution set would be all points between 2 and 5, including 2, but not including 5. All right, now the sign of a product or a quotient. So as long as a product or quotient has an even number of negative factors, then the value is going to come out positive, okay? Because if we multiply or divide an even number of negatives, we're going to get a positive value. If a product or quotient has an odd number of negative factors, then the value is going to be negative instead. Okay, and so what this is going to do for us is once we get some factors, rather than having to actually test every single possibility because there's an infinite number of possibilities, we can actually just determine, well, does each one of these factors come out as a negative or a positive value in a certain interval? And then we can determine if the overall product or quotient is going to be negative or positive based off the number of factors. Okay, now our guidelines for solving nonlinear inequalities would be to move all terms to one side. So if you think back to quadratics and how we solve those equations, similar here, right? We're trying to move everything to one side first. Then we're going to look for factors. Okay, so we're going to see if there's any way we can factor. Once we have our factors, then we're going to use those factors to determine our intervals. Okay, and I'll show you what I mean by that when we get to the example. Then we're going to use a table or a diagram or a number line even to generate what intervals we're looking at and determine if those intervals are going to be positive or negative. And then based off of whether those are positive or negative, that's going to give us the solutions to our inequality. Okay, so there's several steps here, okay, but I'm going to go through all those steps as we go through the next example. All right, so here we go. We've got this inequality, x squared less than or equal to 5x minus 6, and we want to solve. Now, our first step is we're going to move everything to one side. So in this case, I've already got the x squared on the left. I'm just going to move everything else that way too. So I'm going to subtract the 5x, and I'm going to add the 6. So that's going to give us x squared minus 5x plus 6 less than or equal to, and now we have a 0 on the right-hand side. All right, now that we've got everything to the left, now we're going to look and see if we can factor this thing. So I'm going to try to break this into 2 binomials. To get x squared, we need an x and an x. The signs here are going to have to be the same to get a positive 6. So they're either both negative, both positive. Because I want a negative 5x in the middle, though, that tells me they're both going to be negative. And so my factors of 6 are either 6 and 1 or 3 and 2. But because the signs are the same and I need a negative 5x, that tells me I'm going to go with 3 and 2 here. All right, now that we have the factors, we cannot just take each one of those factors and set it less than or equal to 0. It doesn't work that way. So what we're going to do at this point is we're going to take each one of those and we're actually going to set it equal to 0 just to get some critical points that we're going to use to find our intervals. So I'm going to take the x minus 3, set it equal to 0, and the x minus 2 and set it equal to 0. So for that first part, if we add the 3, we get x equals positive 3. Adding 2, we get x equals positive 2. All right, so now what we want to do is we actually want to generate a number line with these values on it. I'm going to draw my number line. 2 is the smaller value, so it's going to go on the left. And then 3 is our larger value, so it goes on the right. Now, what we have to do is we actually have to test values in each one of these intervals to determine if they're going to be positive or negative. Okay, and so this is where it was saying create a table or a diagram. So if you want to use the table, we can do that. So basically, I'm going to put my intervals across the top here. Okay, so I'm going to put 2 and 3. And then down the side, I'm going to put all the factors that we got. We only have 2 factors here. So x minus 3 is one of our factors. And then x minus 2 is the other. And then the bottom row of our table is going to be all of our factors put together. So in this case, x minus 3 times x minus 2. All right, so what I'm going to do next is actually talk about what each of the intervals are at the top of my table. So I know 2 and 3 are kind of the breaking points, which means that this first interval is going to go from negative infinity all the way to 2. The interval in the middle now is just from 2 to 3. And then the final interval is going to be everything bigger than 3, so 3 to infinity. And now I'm going to actually create columns based off of those intervals. All right, now that we've got that, now what we're going to do is we're going to choose test points that we can plug into each one of our factors to determine if we get positives or negatives. So I need some value that's in the interval from negative infinity to positive 2. Well, an easy value to plug in there would be 0. Okay, so I'm going to use 0 as my test point. Okay, but any value that's in that interval would work. Now we need to substitute that into each of our factors here. So I'm plugging it in to 0 minus 3, which is going to give us a negative 3. All I care about there is whether this value is negative or positive. So I'm going to put a negative here because I get a negative 3 when I plug in 0. Now I'm going to do the same thing with the x minus 2. So we're going to do 0 minus 2. That comes out as a negative 2. Again, all we care about is whether it's negative or positive. That's a negative value. Now, the product of those two things, we just need to determine, is that going to be a positive value or a negative value? And if you remember what we just saw on the previous slide, it said anytime there's an even number of negatives in your product or quotient, we're going to end up with a positive value because a negative times a negative should be a positive. And so this row down here now is going to get a positive for that interval. All right, now we're going to do the same thing with each of our other intervals. So we need something between 2 and 3 now. 2.5, probably our best bet there. Again, I'm going to substitute that into each one of my factors. So we have 2.5 minus 3. It's going to be a negative 0.5. Again, all we care about is that it's negative. Then we're going to do 2.5 minus 2, which is going to give us positive 0.5. And so there's a positive there. Now this time we only have one negative. That's an odd number of negatives, and so the overall product this time is going to actually be a negative value. Right, and then finally we just need something in the last interval, something bigger than 3. We'll go with 4. So we have 4 minus 3 is going to be 1. That's a positive value. 4 minus 2 is going to be 2. Again, that's a positive value. And in this case, there are no negatives, right? And a positive times a positive should be positive. So basically what we're saying now is everything in the interval from negative infinity to 2 is going to give us a positive value. So everything on this part of my number line is going to come out positive. Everything between 2 and 3 is actually going to give us a negative value. So everything between 2 and 3 is negative. And then everything greater than 3 is going to be positive again. Now, at that point, what we need to do is determine, do we want the negative values or do we want the positive values? So if we look back at our inequality, notice here, we want this to be less than or equal to 0, meaning that we want negative values. Well, the only interval that gives us a negative this time is this one right here between 2 and 3. So that tells us that our solution is just going to be the interval from 2 to 3. Now we have to determine if these are going to be brackets or parentheses. Well, since this one is less than or equal to 0, using 2 or 3 would actually give us 0 in this case. So we're going to include those values because of the equal to on our inequality symbol. And so that would be our solution now. All values between 2 and 3, including 2 and 3, would be solutions to that original inequality. But again, this is the only way we can actually determine which intervals we're going to look at. Okay, you can't just take the factors and set them less than or equal to 0, because that's just not going to give you the right solution. All right, so now we want to solve this inequality. So we got x times x minus 1 squared times x minus 3 less than 0. Now this time they've already moved everything to the left, so we don't have to worry about that step. They've also done all of our factors for us this time, so we don't have to worry about that. So we can go ahead and jump to the step where we find our intervals. So what we're going to do is we're going to take each one of our factors now, and we're going to set it equal to 0. I'm going to start with my x. I'm going to set it equal to 0. Then we're going to take the x minus 1 factor. We're going to set it equal to 0. And we're going to take the x minus 3 factor, and we're going to set it equal to 0. Well, x equals 0 is already solved, nothing to do there. Add the 1 to the next one, that's going to give us x equals positive 1. And then if we add 3 down here, we're going to get x equals 3. Okay, so now I know my number line. It's actually going to have 3 values this time. 0 is the smallest, then we have 1, and then we have 3. Okay, so our next step is to do our table. Now this time we're actually going to have 4 intervals since we have 3 points dividing them. And so our first interval is actually going to go from negative infinity to 0. Then we're going to have another interval that just goes from 0 to 1. The next interval goes from 1 to 3. And our last interval is going to go from 3 to positive infinity. And then again, we list our factors down the left-hand side. So notice here we have an x. Now, the next factor is technically x minus 1 squared. Okay, so don't forget that this one is going to get a square on it. Right. Then our last factor is x minus 3. Remember, what we really care about is this last line, which is just the product of all of those factors now. All right, so once we've generated the table, now we have to start testing points. So I'm going to choose a value that's in the interval from -infinity to 0. -1 would fit that criteria, so I'm going to plug in -1. If I plug in -1 for x, that's just a -1, so there's a negative value. So we're going to get negative. Now the next one, when I plug in -1, I get -1 minus 1, which is -2. But when I square that value, it becomes a +4. So this is positive. Now, in general, because we're squaring these values, that entire row is going to have to be positive. Okay, so just keep that in mind. We'll see that when we do the rest of them. Okay, but because we're squaring that, everything in that row should be positive. And then our next factor, -1 minus 3, should give us a -4, so that one's negative. And this time we actually have two negatives. That's an even number of negatives, so the overall product should be positive. And so now I know everything to the left of 0 is going to come out positive. Now something between 0 and 1, we'll go with 0.5. Again, we're going to substitute that into each one of our factors. Plugging that in for x, that gives us a positive 0.5, so that's positive. We already said the next one, when we square that value, no matter what, it should come out positive. And then 0.5 minus 3 is going to give us a negative value. This time we only have one negative. That's an odd number of negatives. And so overall, the product is going to be a negative. So everything between 0 and 1 now is going to be a negative. All right, now something between 1 and 3, 2 is probably the easiest value there. Plug that in for x. That's just a +2, so there's a positive value. Next one we said is definitely going to be positive because we're squaring it, so that's positive. And then 2 minus 3 is going to give us a negative. Again, we have one negative. That's an odd number of negatives, so we get a negative here. So everything between 1 and 3 is going to come out negative. And then finally, something between 3 and infinity, I'll just use 4. Plugging that in for x, again, that's a +4. Next row, 4 minus 1 squared. Since it's squared, it's automatically going to be positive. And then 4 minus 3 is 1, so that's a positive. No negatives this time, so overall this has to be positive. All right, now again, we go back to the original inequality now, and we look at our symbol. Well, in this case, we were looking at a less than, which means we want things to be less than 0, meaning they need to be negative. Well, I've got two intervals this time that give us negative values. Okay, so I have to use both of those intervals for part of my solution. Well, the first one goes from 0 to 1. So we're definitely going to have 0 to 1. Now we have to determine, are we including those values or not? Well, because this one doesn't have an equal to on it, it's strictly less than 0. That means we're not going to include those endpoints. So this is just going to be parentheses 0 to 1. And then we have another interval that goes from 1 to 3. And same thing, because it's just a less than, not a less than or equal to, those endpoints are not included. And then because we have multiple intervals here, we just have to remember to use a union symbol to join those two intervals. So our solution this time is all the values between 0 and 1 and all the values between 1 and 3, but not including any of those endpoints. Now notice, I'm not able to just write the entire interval from 0 to 3, and the reason for that is that if I substitute 1, it's going to give me 0, and 0 is not less than 0. So we have to break the interval at 1. We have to separate this into two separate intervals now. All right, so now we have a quotient, right? So we have a rational function, 1 plus x over 1 minus x, greater than or equal to 1. Now, this is still nonlinear, right? Because we don't just have something that looks polynomial in nature that has an x to the first power. We actually have a quotient. So we're still going to want to move everything to one side, right? So that's going to be our first step. So I'm going to subtract the 1 here. It's going to give us 1 plus x over 1 minus x minus 1 greater than or equal to 0. Now, at that point, what we're going to want to do is actually find a common denominator so that I can combine everything on the left-hand side. Well, my common denominator is just going to be the 1 minus x that I have in the denominator of that first fraction. So that fraction is not going to change. It's going to be 1 plus x over 1 minus x. But that means I need to multiply numerator and denominator now by 1 minus x. Well, if I do that to 1, it's going to give us 1 minus x over 1 minus x. And because 1 minus x over 1 minus x would just give us 1. Now we can combine these because we have a common denominator. So remember, I'm subtracting, which means I'm going to subtract each of these terms now. So we have 1 minus 1. That's going to give us 0. So the 1's cancel out. Then we have an x minus a negative x, which turns into addition. So this is actually going to give us a 2x in the numerator now. Over 1 minus x is our common denominator, greater than or equal to 0. Now, just like we did with the products that we looked at before, we're going to take each one of our factors and we're going to set them equal to 0 so we can create our intervals for our number line. So I'm taking the numerator, which is 2x, set it equal to 0. And then we're taking the denominator, 1 minus x, and we're going to set that equal to 0 also. Now, to solve the first one, we need to divide by 2. 0 divided by 2 is still just 0, so we get x equals 0. And this next one, it's probably easiest just to add the x to the other side and say that 1 is equal to positive x, so x is equal to 1 there. All right, so now in terms of our number line, we have a 0 and we have a 1. So now if we do our table of values, this time we need 3 intervals. So our first one's going to go from negative infinity to 0. And we're going to have an interval that goes from 0 to 1. And then an interval that goes from 1 to infinity. Now, if you can get to a point where you can just do these on the number line and just write your pluses and minuses there and you don't need the entire table, that's perfectly fine. Okay, so the table is there to kind of organize things for you to make sure you don't miss anything. But if you get to a point where you don't need it anymore, I'm perfectly fine if you just use the number line. All right, so now we need our factors. This time we just have 2x and 1 minus x. And then we're going to have our quotient of those two things, 2x over 1 minus x. So again, we choose our values. We need something that's less than 0. So I'm going to go with negative 1. If I plug that into my first factor, 2x, 2 times negative 1 is negative 2. So there's a negative value. Next factor, 1 minus a negative 1, that actually becomes plus 1. So 1 plus 1 is 2. That's actually a positive value now. And now when we divide, again, all I have to look at is the number of negatives. Since I have an odd number of negatives, I know the quotient is going to come out negative also. All right, now we need something between 0 and 1. I'll go with 0.5. Substituting that into 2x, 2 times 0.5 is 1. That's a positive value. 1 minus 0.5 is actually 0.5. That's a positive value. No negatives this time, so overall the quotient has to be positive. And then something bigger than 1, we'll go with 2. 2 times 2 is 4, so that's a positive value. 1 minus 2 is actually negative 1, so there's a negative. And now because we have an odd number of negatives, we know the quotient is going to be negative. So in terms of our number line now, we have a negative, a positive, and a negative. Now again, we go back to our inequality and we determine, are we looking at positives or negatives? This time, we want this to be greater than or equal to 0, meaning we want positive values. So that means we're only looking at this interval right here. So I know for sure that my interval is going to go from 0 to 1. And now we have to determine, are we going to use brackets or parentheses? Now, with this one, we have to be very careful. If I use 0 and I plug that in, I'm going to get 2 times 0 in the numerator. 0 over 1 is going to give us 0. That's equal to 0. 0 is perfectly fine. I'm going to include it. But notice, if I substitute 1 into this right here, I'm going to get 1 minus 1 in the denominator. That's going to give us a 0, and we can't have 0 in the denominator. So because 1 makes this undefined, we actually can't include that value even though this was greater than or equal to 0. Okay, so in this case, I do end up with a parenthesis on the 1. And so it is possible for some values to be included and other values not be included, especially when you have these quotients like this, because anything that makes it undefined, we have to use parentheses on that. Okay, so our interval this time is 0 to 1, including the 0, but not including the 1. All right, now absolute value inequalities. So if we have the absolute value of x less than c, that means that negative c is less than x is less than c. So x is somewhere between c and the opposite of c. Because there's no equal to on that, both of the c and the negative c are going to get open circles, and then we're just going to shade everything in between. And then the only difference between number 1 and number 2 now is that we have a less than or equal to symbol. So therefore, we are including the endpoint. So those are going to become closed circles instead. Now, when you have absolute value of x greater than a c value, that actually means that x is less than negative c or x is greater than positive c, right? Because if you want to flip this around, that would give us x greater than positive c. Again, open circles at c and negative c because we don't have an equal to there. But this time, our shading actually goes out in opposite directions, right? To the left of negative c and to the right of positive c. And the same thing with number 4. If we wanted to flip this whole thing around, that would give us x greater than or equal to c. Only difference now, we have closed circles at c and negative c, but we're still shading in opposite directions. So basically, anytime you have a less than or a less than or equal to, these are going to be and statements. And when we end up with those and statements, we're only looking at overlapping regions, which means we're going to shade everything in between those two values. If you have a greater than or equal to, those are actually or statements. And that's when we end up with something like these two graphs, where we're actually shading everything typically in opposite directions. All right, so if we take a look at this one now, we've got the absolute value of x minus 5 less than 2. All right, so what we're going to do this time is we're going to try to rewrite this as an inequality that we can actually solve by dropping the absolute value bars. Well, this time, because it's a less than, that tells us it's an and statement, which means I can actually set this up between two c values, right? C and the negative c. So what I'm going to do is take the 2, I'm going to make it a negative, and I'm going to make it less than the x minus 5 that's inside the absolute value bar, and I'm going to make that less than the positive c value, which is just 2. So basically just take everything out of your absolute value bars. We take the opposite of whatever's on the right-hand side, in this case the 2. So we have a negative 2 and a positive 2 now as our c and negative c, and we put the x minus 5 between those values. All right, now we just need to solve that. This is similar to that second example that we looked at, so I can just add 5. But if I do that, that means I got to add 5 everywhere. So add it to the negative 2 and the positive 2. So in this case, negative 2 plus 5 is going to give us 3, is less than x, is less than 2 plus 5, which is 7. So that would be our solution in this case. If we want to write that in interval notation, because that's typically the way we're going to write most of our intervals, we would say in this case we're going from 3 to 7. And because they're strictly less than, not less than or equal to, the 3 and the 7 are not included. And again, what that means is that every single value between 3 and 7 would make the original inequality true. So if I pick any value there, plug it in for x, when I take the absolute value of that, it's always going to be less than 2. All right, and then this one now we've got absolute value 3x plus 2 greater than or equal to 4. Notice this time our sign is greater than or equal to, so this is actually going to be an or statement. So we're not going to be able to write it the same way we did the previous one, right? Only and statements can be written all together. So this one we're going to actually have to write as 2 separate inequalities. One of those inequalities is going to look exactly like this one, just without the absolute value bars. So we're going to have 3x plus 2 greater than or equal to 4. And then our other inequality is going to be 3x plus 2. And now we're going to flip the sign, and we're going to make this a -4 instead. Now we solve. Okay, so in the first one, we can just subtract 2 from both sides. That's going to give us 3x greater than or equal to 2. And now to get the x by itself, we're going to divide by 3. So we get x is greater than or equal to 2/3. And then the other one, we can subtract 2 there. That gives us 3x less than or equal to -6. And now if we divide both sides by 3, we're going to get x is less than or equal to -2. Notice I did not flip the sign because I divided by a +3. Okay, so it's only when we actually divide by a negative that we need to flip that sign. All right, so now I'm going to actually do a number line for this one just to see what we're looking at, and then we'll talk about what the interval notation would look like. So my 2 values that I get this time, -2 is the smaller, so I'm going to put -2 over here, and then 2/3 is our larger value. Both of these are going to be closed circles, right, because it's greater than or equal to and less than or equal to. So we're going to get a closed circle at -2, closed circle at 2/3. And we want to be greater than or equal to 2/3, meaning we want to shade everything to the right of 2/3. So that's going to look like this. And then we want to be less than or equal to -2, which means we want to be to the left of -2. Again, because this was a greater than or equal to begin with, that's an or statement. And like I said before, most of your or statements, the graphs are going to look like this, where they're going in opposite directions. So now we just have to think about what that interval notation would look like. Well, I've got this interval down here for everything less than or equal to -2. That's actually going to go from -infinity to -2. Because there's a closed circle at -2, I do want to include that value, so I use a bracket. Then we're going to do a bracket at 2/3, and I want everything greater than that. So that's going to go all the way to infinity. Remember, infinities and negative infinities always have parentheses, and if I have multiple intervals, just make sure we put a union between them. So there's our solution set to that inequality. Again, what that means is any value I choose in either one of those intervals, if I substitute it into that absolute value, it's going to come out greater than or equal to 4. All right, so that's all we've got for section 1.8. As always, send me questions if you have them. Send me those questions using the Ask My Teacher button in WebAssign if you have questions on the homework. Otherwise, I will see you next time.